Hello, Professor Sargent here with you again, and we're going to talk about graphing rational functions using transformations. So first we're going to graph h of x equals -2 over all of x plus 2. And along the way, either as we're going or by looking at things at the end, we're going to talk about the domain and range, and then any asymptotes that we might have. So first of all, h of x is a transformation of the reciprocal function 1 over x. First, we're going to shift left 2. And then multiplying by the -2 up here, this is actually the same as -2 times the quantity 1 over x plus 2. That's going to do two things. Both give us a reflection over the x-axis, and it will vertically stretch it. So if we had started with the reciprocal function r of x equals 1 over x, we could put in 1, 2, and 3 and get 1, 1/2, and 1/3. And then apply origin symmetry to get -1, -1, -2, -1/2, and -3, 1/3. I'll write related things in just a moment. But if we're shifting left, and we want to get the same y values before we do the reflecting and stretching, reflecting over the x-axis and vertically stretching, well, here's what we're going to have. Those original x values are now the x plus 2 values. So that putting in 1 over x plus 2 here, we'll get the same y values. We can't put in 0. That's going to make this undefined, or UD for short. And then our origin symmetry. You have to work backwards to find out what we're putting in for x then. Either do some algebra, solve x plus 2 equals -3. Well, you'd subtract 2 from both sides and get the x equals -5. But isn't that the same as going left of -3 by 2 units? Left 2 units. So do the same here. And here. And even though we're going to get something undefined here, 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 and here. Those are the x values of the coordinates. Those are the x coordinates of the points we'll plot. And then the y values, we have to multiply all of these by -2. It's going to give us 2/3, 2/2, or 1, 2, something undefined multiplied by -2 is still going to be -2, -2, -1, and -2/3. Zoom in on that in a moment. So again, we look at the beginning column and the ending column to know what points we're going to plot. -5, comma 2/3, -4, comma 1, -3, comma 2, -1, comma -2, 0, -1, and 1, comma -2/3. Those are the points that we're going to plot. All right, so here are those 6 points. We're getting, just like with the graph of the reciprocal function, r of x equals 1 over x, two things that are separated by the vertical asymptote. It's like two branches of one function. In fact, although those of you taking a class from me using an online homework system, it's going to tell you to look at the final graph to determine things like domain, range, and then asymptotes. Well, we already know that x equals -2 is going to give us a vertical asymptote. Show that as a dashed line in a different color because it is not part of the rational functions graph. It's just related to it. There we go. So our domain is x not equal to -2. And our range, well, we'll get to that in a minute, but going hand in hand with the domain, x not equal to -2, whether you have to put that in set builder notation or interval notation, I'll leave that part of exchanging how you notate it. But vertical asymptote at x equals -2. And so you can combine, connect these 3 points over here in this branch and these 3 points over here in this branch. And although this website is not putting arrows at the end, they're there. As for the range and whether we have any horizontal asymptotes, well, the degree of this in the numerator is 0. The degree of this is 1. And whenever the degree of the numerator is less than the degree of the denominator, y equals 0 will be the horizontal asymptote. And again, I'll switch that color and style. You can see that at the far left and the far right, that the curve is getting closer and closer to it. Although a vertical asymptote cannot be crossed, a horizontal asymptote could be. We haven't quite gotten to that yet, but it could happen. In this case, it's not going to happen. There's no way to have a value of x that would make this equal to 0. Y equals 0 is our horizontal asymptote. And that gives us our range is that y is not equal to 0. If there was a horizontal asymptote being crossed, then we'd have a little more to worry about in terms of figuring out the range. As for oblique asymptotes, you're never going to get them at the same time that you have horizontal asymptotes. So just to make sure that you can see this part. Again, domain and range. Do they want that written in set builder notation or interval notation? This is not in either. I've just expressed what x and y cannot be equal to. One more coming up in just a bit.